Hello and welcome. My name is Doug Picklyk. I'm the editor of HPAC magazine, and this is a live 30 Mechanical Minutes, our free webinar series that we do, virtual content for real-time professionals. Joining me today, I've got two hydronics industry legends, if I can, Mr. John Siegenthaler and Mr. Robert Bean. And we're going to be talking about what's hot in hydronics. So first, before we get going, I'd just like to thank our sponsor for today's 30 Mechanical Minutes, and that is IBC, manufacturers of boilers, combi boilers, water heaters, and the new HPX series of air-to-water heat pumps. You'll find them here at CMPX at booth 1303 by the main entrance. So thank you very much, IBC, for your support today. Tom. As always, 30 Mechanical Minutes, we aim to keep this to 30 minutes. But we want to make this as interactive as we can. So with our live audience today, if you have questions, just please raise your hand. And for those of you online, we'll try to get to as many questions as we can. And I did send out a request for questions prior to this event, and I did get a question, so that will be asked just a little bit later in this program. So very quickly, for those who are here today who may not be familiar with our two guests, I'm going to allow them to do their own little introduction and give you a brief bio of who they are and why they're here today, perhaps. So, John?
Well, I have the opportunity to come up to Canada where people take hydronics seriously, and I enjoy coming up here. We had a great turnout this morning. Over the years, very good turnout. I know there's a lot of passion about hydronic heating up here in Canada, and again, my privilege to come up and do some training and walk around the show here. So, thank you.
Okay. Robert, where are you from?
Well, evidently we're
where
legends.
Did you come from?
That makes us old. So I don't actually remember where I came from. No. Yeah, I'm Robert Bean, and I'm a retired practitioner in the building and mechanical world, and I'm here. I was here yesterday giving a lecture on decarbonization, kind of as a precursor, I think, John, to your lecture that you gave, workshop yesterday. So we've kind of been doing that off and on for the last few years, taking our knowledge, our combined knowledge, and educating not just hydronic contractors and engineers, but anybody that has to do with buildings, architecture, mechanical.
The whys in the house, right?
The whys in the house.
Yeah. The whys in the house. I was going to just comment, we're located today in what's kind of called the social hub, and we're kind of surrounded by influencers here, but I really think you guys are the OG, the old guard when it comes to influencers in this industry, especially when we're talking hydronics. So thank you guys again for being here today. And let's get going. So I know you both were attended AHR in Chicago, and you guys are obviously been here for a day and a half. So as you walked around, everything that you're seeing and hearing, where's hydronics technology going? What's happening in hydronics? John, I'm going to start with you and just kind of give me that.
Sure. Yeah, hydronics for decades, really, the Achilles heel in hydronics has been, what do we do about cooling? And I'm sure some of the people here have probably had projects or potential projects where you have a client that's interested in hydronic heating, but the question comes up, well, what do I do about cooling? And sometimes you lose the project over that, or you refer to a separate contractor. The availability of heat pumps, specifically air-to-water, as well as geothermal water-to-water, is an answer to that question. And at AHR, there were several companies rolling out new air-to-water heat pump products, and as well as water-to-water geothermal, all of which can be applied in hydronics. So hydronics should be thought of as heating and cooling at this point, and that opens up a lot of opportunity.
Yeah, and what I've been saying for many, many years is hydronic is the great enabler. It allows the COPs to be extracted out of the machines that the engineers intended it to be. And without using hydronics, you'll never be able to achieve the COPs that are built into the equipment.
Right.
And so what we're seeing is people understanding that at a higher level and then designing their systems for really low temperatures and heating and really high temperatures and cooling, and that's just awesome to see that.
It's something you've been talking about
For a long,
for a long
long
time.
time.
Yeah.
Okay.
When OG was not old guard, it was old geezer.
Yeah, and utility rate structures too. Hydronics is going to enable things like thermal storage, load shedding, off-peak rate structures, coordinating the operation of the heat pump, and perhaps even with a boiler. So as we go forward into this electrification, pace, a very rapid pace, you as hydronic professionals, you have something utilities are interested in, because as you were saying, it's enabling this coordination with what will be more off-peak rate structures, time of use rates, and so forth.
Yeah, and this is a good point that John's making, and that is that energy comes in many forms, and thermal storage has a huge role to play. Everybody's so focused on electrical storage, and it has its own issues, but I can't think of a better storage mechanism than water, and being able to extract that energy out and then dump it back in at optimized times. Yeah.
That's right. You guys, fortunately, you were both in Vancouver with us at the Modern Hydronics Summit just this last September. And it was at that event, the keynote that you guys did in the morning for us, you both made the comment that you were complimenting everyone who was in the crowd, suggesting that, I want to make sure I got this right, that at this point in time, it represents the greatest opportunity that you've ever seen for the hydronics industry in your lifetime. And I just wanted to know if you could both kind of back that up a little bit more and give me a little more insight as why you believe that to be true.
Yeah, I mean, over the last 3 or 4 decades that we've been in the industry, opportunities have come and gone. One of them was demographically based, which we're starting to see the tail end of that, where people had money to afford hydronics. But now it's a little bit different opportunity, and the opportunity again goes back to this enabling, the hydronics being able to enable optimization of designs and equipment. And this is an opportunity that started about probably 5 years ago, I would say. I don't know, John, if you sort of have a feel for that. When we started to see energy structures change, we started to see the globe, the world start to respond to renewable electrification, decarbonization. But this is not a flash in the pan opportunity. This is something that's going to last for decades. And getting in on that now, establishing yourselves as experts, knowledge, resources is huge.
Yeah, and one of the things I would tell everybody, you need to be advocates for hydronics, and it's not just about the heat source, which is an important thing to understand. Over those decades, we've seen solar thermal, we've seen biomass, we've seen pellet boilers, all these different devices come in, and oftentimes people get wrapped up in the performance expectation of a heat source, and it's sort of like getting wrapped up in the performance of a Ferrari racing engine and saying, I'll just drop that in my Cub Cadet lawn tractor, and I'll have a great racing machine, right? So you need to, in a sense, preach the benefits of hydronics, one of which is distribution efficiency. The idea that you can move heat through a building easily on 10% of the energy that would be required with air. So as energy planners look at devices like heat pumps, oftentimes they don't look beyond that source. They don't look at the total system. What is the potential there? Not, thermal storage, obviously, but low energy to move energy through buildings, low distribution energy is a huge benefit of hydronics. So,
yeah, and that's why I think we're going to see, as time goes on, thermal networks within communities. So not only within the building itself, but to be able to move energy back and forth between many buildings in a development.
District energy solutions.
District energy, tri-energy, cogen, all of that. Yep.
Yep. Okay, we're just having a short pause here online. We're just got an overhead announcement. Here we go. I'm going to keep on going because we're talking a lot of good things about hydronics. You know, there's great opportunities, but it still remains quite a niche for some. I would say a lot of people in the crowd. So, what are kind of the main challenges that hydronics continues to face? As a market to keep growing this market?
Well, Robert, you were talking about this too. Look beyond just the pipes, the pumps, and the boilers. Look at what's going on in the construction industry. And in one sector in particular, net zero. How do you keep hydronics relevant in net zero? That's one of the fastest growing segments of the, not only residential, but in commercial buildings. And what I've seen over the last few years is oftentimes people that are teaching builders or architects about net zero construction, they will default to ductless mini splits. Basically saying, this is all you need to know about heating and cooling. Put in a ductless mini split. And they view hydronics as overly complex, and quite honestly, in some respects, I don't blame them, because oftentimes we've seen photos of, 30 circulators on a wall, $10,000 worth of controls, and this is residential. And there are places for that, I will concede that, but the average Joe there's no way he can afford that type of a system. We need to keep hydronics relevant in average construction, and in particular, tie it in with net zero. Heat pumps, photovoltaics, low energy building envelopes, it's a perfect combination. And we can't let that as an industry slip away to ductless mini splits, quite honestly.
Yeah, and it's, as you see these loads drop in buildings, the percentage of the load shifts more to make up air, for example, or ventilation, but domestic hot water. And so water and heating water will always be a requirement, but there also will be, in cold climates, a small need for heating and a small need for cooling. But again, it goes back to, for us to keep hydronics front and center, we have to get it simple again, get it back to where it should be, which is simple systems. But also, as John and I have both been preaching for many, many years, it's part of an integrated solution. The hydronics is one piece of it. And learning about buildings, about windows, about air tightness, these are also important elements to keep in mind as well. Yeah.
Well, so Robert, this is specific for you. You were involved in a whole new track at the ASHRAE Winter Conference in Chicago this year, and you participated in a standing room only forum on why do we have so much thermal comfort illiteracy within the architectural and engineering community. And my question is, what did you learn? And is the engineering community getting on board? Are building designers recognizing the benefits of hydronics for energy efficient thermal comfort?
One of the things that I learned, never underestimate the desire for people to learn about thermal comfort. When we booked that room, we were thinking 20, 30 people. As it turns out, it was like 100 people that came to understand why thermal comfort illiteracy exists. And the big thing that there was many things we learned, because we had architects in the crowd, engineers in the crowd, contractors, and these were representative of everything from property developers, the government, healthcare facilities. And the big thing was communication. What occupants tell us is that we're doing a terrible job being in compliant with ASHRAE Standard 55. And for those that aren't familiar with ASHRAE Standard 55, that document was published in 1966, and it actually establishes what are the conditions for thermal comfort. It's not air temperature, for those that think that you know thermal comfort. It's not air temperature. There's like 11 different metrics. Radiant is one of them. And so being able to have all those people in the audience to talk about that and get them to understand that a dry bulb thermostat does not represent thermal comfort because it misses the radiant exchange. I don't know of any other system other than the building performance itself, than radiant floor heating, that can create compliance with one of the oldest standards that ASHRAE has. It's very powerful. Yeah.
Okay. Good. So that's what you learned.
I learned, yeah. We need to do a better job of getting that information out there because people are
Yes.
asking for it.
Yes.
Yeah.
Okay. This one is a little more targeted, not necessarily only residential, but John, you brought it up, radiant cooling. And is it a reality or a pipe dream? I mean, people have talked
No
about
pun
it. but
intended.
yeah. How do you compete with forced air in the eyes of the consumer, I guess, when it comes to cooling?
Now, in a residential context,
Let's start with the residential.
yeah. I'll be very honest. I think right now, if you're just getting involved with small scale chill water cooling, I would not advise you to go to radiant cooling at this point. I would advise you to start with an air handler and learn how to insulate piping properly. It's a different installation in terms of especially pipe insulation. It sounds like it's a no-brainer, right? I just throw the foam on the pipe and I'm done. We've just seen it messed up too many times. So radiant cooling is good, and it's very useful in commercial buildings. It's very good for sensible heat absorption. I don't think our market is quite ready on a residential scale for it. Complications with dew point control, making sure that you're measuring dew point, controlling your temperature right. You can't afford to mess it up. It can make a mess in a hurry. So as heat pumps come into the market, I firmly recommend that contractors that are doing hydronics learn how to do small-scale chill water cooling, but walk before you try to run. Start with an air handler, maybe a couple fan coil units, make sure you have condensate drains in there, learn how to insulate the pipe correctly, and at some point I think we may see it, but right now, my understanding, the costs are pretty high to do it because essentially it's European controls coming over here that, there are products on the market to do it. Walk before you can run. Start with an air handler, I shouldn't say get your feet wet, should I? That's probably a poor comment, but make sure you understand that chill water can create a lot of condensate, and you don't want that all over the floor and all over the piping. And if there's any pump manufacturers listening, please come up with insulation shells for your circulators so they don't turn into balls of rust in 6 months with chill water.
Yeah. I've heard you say that one before, and it's still true to this day.
But it's important to note, though, it's not a technical problem. Right. I want to make a statement that 100% of all condensation problems in buildings conditioned exclusively with air did not have radiant floor cooling to blame. So where did the problem come from? It came from the moisture. So moisture is the problem, not the floor cooling. That's really important. So it's not a technical problem. It's people understanding what the challenges are and having the skill set to make that operate properly.
Okay.
Yeah.
Well, there's no question that the heating and plumbing contractors, and some of them in this room, get pretty excited about hydronics. I see it on Instagram every day. There's beautiful installations. People love what they do. But the contractors love hydronics. But how are we able to inform customers, consumers, that hydronics is the way to go as well? Get them excited about hydronics-based systems. What's the solution there?
Probably depends on the customer. Some customers are motivated by aesthetics. So they don't want to see radiators, they don't want to see baseboard. We've had clients, they strictly don't want fossil fuel. That's their starting point. I don't want any fossil fuel. And the nice thing about hydronics, you can have these customers starting from different points. Like, is it aesthetics? Is it, I want to eliminate fossil fuels? Sometimes you'll get a technically minded, we've had clients over the years, they want to build their own computer-based control system and run their house on that. That's kind of dangerous in some sense. But hydronics is flexible enough so you can start from what is the objective? What are they trying to accomplish? I think aesthetics, it's certainly comfort. comfort. And I made that mistake early on in my career, you know, from an engineering standpoint, getting excited about outdoor reset control and cross-link polyethylene and variable speed injection mixing and all the technology, and talking to consumers about this. And I realized that's just, for most consumers, they don't care how you do it. They just want the comfort. So never, whatever you do, be it with heat pumps or, you know, 10 years down the road, whatever that is, you can't forget the comfort part of it. You've got to start. And one of the things I would stress to you, whatever the technology is, if it's a new technology like air to water coming into our market, if it doesn't produce comfort as good, if not better, than what we've had in the past, it's not going to hit a mass market status. You know, I would consider myself, you probably are the same, heating hobbyists.
Right.
At times, right? We'll try a little of this and a little of that, and you know, our house has got a lot of different stuff in there, and my wife's after me, when are you going to write the manual so when you kick the bucket, somebody else can run this house? Most consumers are not heating hobbyists. You know, they're really not into the technology, they're into the comfort. So make sure you're always delivering that comfort, and with, I would start the conversation right up front with comfort, and quite honestly, get them in, get their socks off, and put them on a radiant floor.
Yeah. Yeah,
on a cold day, when their feet are cold.
Yeah.
The radiant floor always seems to be the selling point.
Yeah.
Yeah. Robert, this one's for you. Are fossil fuels going away? And can you explain exergy in 10 words or less?
No, fossil fuels will never go away because we'll always need high quality fuel for doing high quality work, like power generation, right? Like moving planes, moving ships, freight liners. These are all high energy, high quality energy demands. But for housing, we don't need such high quality fuel. So fossil fuels won't go away. We're just going to focus them on where they're really good, and they're not good for housing. And that is really what exergy is all about. Exergy describes the quality of energy, and exergy efficiency describes how efficient are we using that quality. And to put that into practice, when we take gas and we convert it to a flame, 3,100 degrees Fahrenheit, 1,700 degrees C. What's the temperature that we need to run a home at, air temperature? 72 degrees Fahrenheit. Well, 3,100 degrees Fahrenheit to heat 72, that's bad exergy, because we can use solar thermal, which generates 212 degrees Fahrenheit.
Yeah.
212 degrees Fahrenheit is way closer to 72 degrees Fahrenheit than 3,100 degrees is. So solar systems have a very high exergy efficiency, where natural gas has a very low exergy efficiency.
Right.
That was not 10 words.
No, it wasn't.
That was just 10 seconds, maybe.
10 seconds or 10 sentences. Okay, but that's fine. So I did put out a request for questions from people out in the world prior to this session today. And I received one from Lachlan Harrison, who happens to be in the crowd today, I believe. They're front, back, and center. So here's the question. Hello, John and Robert. What kind of troubles can you expect when you oversize the buffer tank in an air-to-water heat pump system? Right? Did you get that?
Oversize the buffer tank in an air-to-water system? Well, cost, for one, you know, obviously cost, but I'd much rather see you oversize it than undersize it. You know, within practical limits, I really don't see too much of a downside. You know, obviously cost. We're seeing systems now, buffer tank volumes, 20 gallons maybe, 30 gallons, something like that. But again, distinguish between what's the purpose of a buffer tank versus a thermal storage tank. Okay, if you're trying to store thermal energy in water and you're trying to cycle through a fairly wide delta T, bigger the better. I mean, it's a bigger battery. If it's just a matter of moderating what the the heat pump or the boiler, what its performance envelope is relative to what the load is. Oftentimes, a smaller buffer tank is fine. And there are heat pumps on the market now that are going without any buffer tank. And a good generic example, let's say it's a fire station, slab on grade, tubing into floor, so we've got low temperature floor heating. Let's just say it's 1 or maybe 2 zones. We've got a lot of thermal mass in that concrete. We don't need a buffer tank. We don't need extra thermal mass. So we just have to couple the heat pump to that thermal mass, and I'd suggest a hydraulic separator in between that allows you to do constant circulation in the floor and just meter heat in from the heat pump as you need to. So there definitely are situations where you don't need any buffer tank. The flip side of that is, let's say I want to do 10 panel radiators in a house and put a TRV on each one of them. Now a buffer tank is still a good idea in most cases. So really, to answer your question, I don't, whether it's an 80-gallon tank or a 100-gallon tank really isn't going to make a lot of difference other than cost. I don't see any need to go to, multi-100-gallon tanks for buffering, but that's a different situation from thermal storage. Depending on how much energy and what time frame you have to grab it, you may need a large thermal storage tank or multiple tanks to do it. So.
Did you actually have a concern? Were you thinking of something that we were not thinking of? We can't hear you. Oh, seasonal changeover.
Okay.
Seasonal changing.
Oh, yeah. If you've got a building that could have simultaneous heating and cooling demands, you probably want a 2-tank system.
Yeah.
So you're going to have a hot tank and a cold tank. But if it's a more typical envelope-dominated load situation, I live in upstate New York, and our heating season ends, maybe end of April, and then we're just kind of a dead band. We don't really need cooling until well into June. So the buffer tank would equalize. You definitely don't want to go back and forth between heating and cooling on a single buffer tank. So I guess Calgary, you get the Chinooks, right? So it can be really cold at night, but nice and warm during the day.
Yeah, easily we can get 20, 30 degrees.
Yeah, so that your solution is probably 2 buffer tanks.
Yeah. Or, and we've never talked about this, but to reject the heat from the tank. Like mechanically cool it down, take the energy outside. But that same coil that could be outside could also provide free cooling during the nighttime. So you could do evaporative cooling on a coil, bring that chilled water back into the tank. So use it to discharge energy when it's too hot, but also use the same.
Yeah.
We just solved like a major problem, like in seconds here.
Well, okay.
John, there's an article for you.
Yeah. Chilling your buffer tank.
Chilling your buffer tank.
This is the last question that I have, unless someone in the audience has a question they'd like to ask. And it's really just about resources for people to learn more about hydronics. Tell me what you know, where people can go to.
I always point to John.
Yeah,
there is no better resource than John Siegenthaler.
Well, there's a lot of resources out there. There is this guy that wrote a book, but I'll leave it at that. Anybody here get the hydronics publications from Calefi? They're free.
Yeah.
Every 6 months there's a new issue. That's a resource that's out there. There are training programs. HeatSpring has courses on hydronics. They have courses on air-to-water heat pumps. They have courses on geothermal. And many of those courses, not all of them, but many of them are free. So heatspring.com is a website you can go to and look through the offerings that are out there. What am I missing, Robert?
Well, I'll put in a plug for ASHRAE. We have a committee, TC 6.1, which is dedicated to hydronics and steam. But we also have affiliated committees, Radiant, which is 6.5, District Energy, which is 6.2, I think it is.
Okay.
And we're always putting on courses, at least twice a year at the conferences. But then we also have the ASHRAE Learning Institute, and we're also doing courses through that as well. So.
Okay.
Yeah, I'll throw one other thing in. As you dive into kind of continuing education, again, don't limit it to just hydronics. Watch the building market. Watch what low energy architects and builders are doing, and keep asking yourself the question, how would I fit a hydronic system to what they're trying to accomplish? Okay? So you do need to have that peripheral, we're building integrated systems, so it's the building and the system working together as one. So, don't isolate yourself into just hydronics. Look at that building market. Watch what's going on with heat recovery ventilation is a good example. Yeah. I know it's mandatory up here in new construction, right? So imagine a system based on a heat pump that is doing space heating, cooling, domestic hot water, and heat recovery ventilation. You tie the heat recovery ventilator into the same ducting system that is doing your cooling. And we just did a cost comparison. We had kind of a challenge of, should I do a bunch of mini splits and throw a heat pump water heater in there plus an HRV? Or could I use a central air to water heat pump, do heating, cooling, indirect domestic water, and also tie the HRV in? And the cost came out very similar in our New York market. So it isn't always a case about, the hydronic solution isn't always the most expensive option. So really, when you nail it down how you can integrate components together, you can actually be very competitive against some of the other alternatives that are out there.
Okay, I think that's awesome. I'd also like to mention HRAI, the Canadian Hydronics Council. These sources, there's also places to find hydronics education. And of course, don't miss an issue of HPAC magazine, because you'll find something from John Siegenthaler in every one. So with that, thank you, John and Robert.
Yeah, thank you.
Thank you everyone who came and took advantage of this today. Thank you to everyone online. And of course, thank you to our sponsor today, IBC. Your support is greatly appreciated. And again, for those of you here, for more information on IBC, visit the Ream booth by the front of by the main entrance, booth 1303. And of course, that's it. That's it for another episode of 30 Mechanical Minutes.
All right.
And a recording of this session will be up on our website in the not too distant future, as soon as I'm able to edit and get it up there. So with that, until next time, thank you all so much for joining us, both at home, I think that camera's on, and everyone here. Thanks a lot.
Thank you.